Hey guys, here is your Week 8 MyStatsLab Problem 5 example. Suppose that you're testing the hypothesis, and a null hypothesis is P is equal to 0.19 versus the alternate that P is greater than 0.19. A sample of size 270 results in a sample proportion of 0.26. Part A asks us to construct a 95% confidence interval for P. And for that we need three pieces of information here. The first thing we need is p hat. Well, we know from our problem that p hat, our sample proportion, is 0.26. And from that we can also find q hat, since it is equal to 1 minus p hat. And of course n, our sample size, is 270. The next thing we need is our standard error. And from doing this many times so far, we know that the standard error of p hat will be equal to the square root of p hat times q hat divided by n. So let's put in our formula here. Equals, start typing square root. There it is. And we're going to use two sets of parentheses here so we can keep our top together at p hat times q hat, close those, divided by n, close it completely, hit enter, and there we have our standard error is 0.02669. Now, to complete our confidence intervals, we also need a z-score. Well, if you look on page 312, you will see a blue box, and at alpha 0.05, which is what we have since our confidence interval is a 95% confidence interval, and it's two-sided because confidence intervals have two sides, an upper and a lower, and we see from the box there that our z-score should be 1.96. Now we can go ahead and complete our upper and lower limits for our confidence interval by using our formulas here. And to find our lower limit, we're going to use equals p hat minus our z-score times our standard error. Hit enter, and there is our lower limit, 0.208. Now, to construct our upper limit, we're going to say equals p hat plus, this time, our z-score times our standard error, and there we have our upper limit. So part A, construct a 95% confidence interval for P, and we have a confidence interval with a lower limit of 0.208 and an upper limit of 0.312. Okay, so part B of our problem asks us, based on the confidence interval, can you reject the null hypothesis at an alpha of 0.025 and explain that? Well, confidence intervals and hypothesis tests are built on the same calculations. They have the same assumptions and conditions, and a hypothesis test can be approximated by examining the confidence interval. Now, the question asks us about alpha at 0.025. We just found a z-score at alpha 0.05 because our confidence interval is a 95% confidence interval. Well, we know confidence intervals are two-sided, upper and lower, but we can use those results and look at a one-sided test. And in this case, we know that with a null hypothesis of 0.19 and our alternate at p is greater than 0.19, that we're just going to leave off the lower 2.5% and go from there up. So we can look at this with an alpha of 0.025. Now, in this problem, our null hypothesis is that p is going to be equal to 0.19. and our confidence interval has us at a lower limit of 0.208. And since our null hypothesis of 0.19 is actually less than 0 excuse me 0.208, then we know that it falls outside of that interval, and thus we can assume that p is going to be greater than 0.19. So there you go, that's part B. Now part C and D ask us a couple of questions. Part C asks us, what is the difference between the standard error and standard deviation of the sample proportion? Well, we can state here the standard error is based on the sample proportion, and the standard deviation is based on the hypothesized proportion. And then part D, what is used in computing the confidence interval? Well, we know from our calculations up here that the standard error is used in computing the confidence interval. Well, there you have it, guys. There is your Week 8 MyStatsLab Problem 5 example. See you next time.